travails. Oh, I know.
Okay, so that's the Mac microphone. That's not this microphone. Okay, this microphone is giving me so much shit. I don't know why
It's not working, but
okay. Yeah, so it's probably pretty quiet. We can turn it up a little bit here. Okay, so I'll work with that for now. Yeah, it's honestly such a hassle. Um, Thank you for letting me know though. I was muted this whole time. I didn't even realize. Um, okay. What am I coding today? Okay, so this mic is garbage. I have to order a new one. That's so freaking shitty. Okay, well, I guess I'll just use my laptop's microphone. I hope it's loud enough. Let me know. Okay. Yeah, let me know if there's any mic issues. But I'm coding today. I'm doing a binary search tree implementation, Nathan. Yeah, yes, and thank you for that, though. I appreciate that. Binary search tree implementation. Right now, I'm just building the build tree function. Yeah, I gotta order a new microphone. This sucks. You don't think I'd actually need a mic? So the mic on the built-in mic on my MacBook's all right. It's not too bad. If you say it's not too bad, then maybe I won't order one. Because I ordered this sucker just for this channel, and it's like basically the doesn't make a significant difference. That's fair. Well, we'll see. And I bumped the connector on the like undersized. It's kind of hard to see, but there's like a USB. You're currently at my stage, Yasin. Nice. Best of luck to you as well. But yeah, no, I bashed the connector, the USB connector, and I think the port is partially dislodged from the chip inside of the microphone, so it doesn't really connect properly. And it's been nothing but a hassle since I've gotten it, so I'm not really a big. I thought like Blue Yeti would be a good name, but it's not really been that great. Like it's a good mic when it works, but you know that connector issue is really annoying. But if you say the built-in mic on my MacBook's okay, then I'll probably just roll with that then for a while. But I mean, ideally, I have a dedicated mic. But yeah, no, it's okay. So this is basically what we're trying to do. We're trying to do this implementation. But basically, to build the tree, we have to sort the array that's given because we're constructing a binary tree from an array, right? So we have to sort it, and we have to remove its duplicates, right? So I don't know why this. Is not going to do this. If actually, I'll just do like value number. What the value type of node is not callable? Oh, new node. Sorry. Okay. Function lacks ending return statement. Oh, actually, I could just return undefined. No. Type notable. A binary tree, Nathan, it essentially acts as a data structure to allow for storage of data that can be retrieved in log n time, pretty much. So it's essentially yeah, like if we go to the, let's go to the explanation. Yeah, see, fast lookup. So log of n, because you only need to make right or left decisions, right? So like, let's say we have data stored in 14. Instead of accessing an array, like let's say if we had the data stored in an array, to get to 14, at the very worst case, you might have to traverse the entire array to get to, like, assuming it's a linked list, right? So in like a linked list, to access data in a linked list, you have to, at the worst case, traverse the entire linked list, right? But in a binary tree, you can just make decisions by descending the tree. Like, you either go left or right. And then that traversal turns out to be O of log n for an average search time. So in the worst case, of course, it would be O of n, because if the binary tree was just like, it only had left children or something, then that would just effectively be a linked list. But yeah, no, it has a average case complexity, or average search of log n, and deletion and insertion. Why am I using Wikipedia? It's just the it was just the link from this here. It was just to illustrate the example of binary search trees. I'm not actually using it for anything, although the Wikipedia entry is pretty good, I think. Okay, so anyway, so yeah, that's what I'm doing. Same as adding default objects into an array. What do you mean by default objects? Okay. So what do we want to do here? Function whose declared type is neither. Oh yeah, okay. This is gonna give me hell here. Let's just do it like this. Okay, so if the values are not equal, then we add it to or not append, sorry, push. This typing issue is driving me nuts. Parameter, argument of type number undefined. Yeah, exactly. Yeah, it's a good way of sorting the array so that access, insertion, and deletion is O of log n. Or, I guess, theta. Big theta of log n. I don't know why this isn't working now. It's just more typing problems. And like return here or something. Does this fix it? We assert it. Yeah, we can. Okay, that's fine. So I think this works. Let's just make sure. So we'll say let's just do 1 1 2 2 3 3. And then this should yeah, okay, it removes the dude, why is this trying to translate from radio? Do you need to learn testing framework as well? Do professionals actually use it? Yes, they do, Nathan. It depends on the scale of the project you're working on, but you should learn a testing framework. I'm not actually going to implement testing in my projects yet, although I should. But if it's a serious project, I'm probably going to. But no, professionals, especially in like real jobs, use testing frameworks for jobs JS. Let's see, Mocha, Jest, Karma. So it's also used for mocking as well, which is to test for large implementations if you need to abstract part of the code to just get it to work for the test, then it provides that as well. The Odin Project teaches you Jest though, which is the good news. So these are the links that are provided here, I think. So I'll try and do it without looking at the documentation, but anyway. All right, so this array removals thing works just fine. Or removal, like duplicate removal. So yeah. All right. They pay the same salary as a car dealership sales guy, do they? Where specifically, Nathan? Oh, Europe. I see. Well, I mean, car salespeople can make pretty good money, depending on how good of a salesman you are. So, I guess it wouldn't be entirely a bad thing. I mean, it's similar in Canada too. I'm not gonna lie. Canada's pretty high tax, but we have good public services, so it's not the worst ever. Same thing with Europe too. Like you get like university for free and stuff like that. In a lot of places. I mean, it's not true everywhere in Europe, but you know. Anyway. Okay, so this is our thing. And then we have to do our, I guess we could do an iterative approach, because I feel like a recursive method is a little bit, it's probably more elegant, but it would be a little bit more confusing in this context. Yeah, sounds good, Nathan. Appreciate you dropping by. Read this article on building binary. Okay, so then this is the queue approach, right? Recursion. What was my starting point? So I've been through this before, but my starting point was way back. Well, okay, wait, actually, first, before I get into this, by starting point, what do you mean? Do you mean with this specific journey, or like with programming in general? Because I could give two different answers. Because with this specific journey, I just started like 6 weeks ago. Because I wanted to actually learn web development properly. And programming in general, okay. So basically, I taught myself how to code sort of when I was young, like around 11 years old. I used a game engine called Game Maker, which makes 2D games and stuff like that, and it uses this language called GML. It looks really different now, but it uses this weird language called GML. It's pretty much like C syntax, right? Anyway, so I learned the basics of programming, like variables, basic data structures, etc., when I was young, and then I didn't touch it for like, probably around a decade. Once I got into high school. And then I did a degree in biology, completely different. I thought I wanted to be a teacher. But then I didn't. I changed my mind over the pandemic, and then I went and got a accelerated computer science degree in 2023. I did the computer science degree, graduated in 2025. However, I feel like I didn't learn a lot in it. I feel like it was very math heavy and theory heavy, which was fine, but it didn't teach me actually like how to take the theory that I'm learning and apply it in code in the same way as like actually just practicing how to code. So, I was kind of stewing with this, knowing that this was a problem, like not actually knowing how to code, even though I'm in a computer science degree, right? Like I did know how to code, but it was basically just like scripting, right? It was just like using Python to like implement pseudocode, stuff like that. It wasn't like actual like coding, like building projects and stuff like that, right? So I decided, you know what, I'm going to take that knowledge that I gained from my CS degree, which is limited, I'm not going to lie, and I'm going to channel it into learning something more practical. And I decided to start with web development because I feel like most software development has web dev as a foundation, or at the very least it's a good foundation to kind of, explore what your interests in professional programming and stuff like that, right? And I was like, you know what, like, I work a full-time job in IT. I didn't really have. I kept telling myself I was going to start, and I didn't really end up ever starting. And I was kind of sitting in this job for 9 months. And I was like, you know what, screw it. I'm going to use the internet to hold me accountable. And then I started this channel to hold myself accountable. And now here I am, 6 weeks later. So right now I'm trying to gain the logic behind coding, kind of, yeah. So basically, what I'm trying to do, Yasin, is take. Use the Odin Project as a guide to apply the theory that I do understand, as well as new theory that I learn in an actual programming language with like real like web technology. So I'm using vanilla HTML, CSS, and TypeScript. Because TypeScript is industry standard, at least I think. Maybe the narrative is shifting, right? But I think it's good to know. And I also have been seeing a lot of the AI hype bubble, and like I know everyone's scared about AI, but I really, after I studied the math behind machine learning, and I could be completely wrong. I'm not going to claim I'm right, but I don't think AI is going to take away developer jobs. I think if you say that or you think that, you're a little bit naive, only because the AI isn't conscious. It doesn't understand what people want in the same way that people do, and it will always make mistakes for as long as the architecture looks the way it is, right? Because LLMs are merely input-output machines. They don't really hold state that well, right? Like you see that with the limited context windows and the hallucinations and all that stuff. So I think AI is a great tool to accelerate development, but I don't think it will replace us, which is why I'm learning how to code by hand, so that when I use eventually, I'm probably going to use AI in my work in some capacity. I'll be able to understand what the AI is producing and, have a what's the term? Like, not veto power, but I'll essentially be able to critically analyze what AI produces and tweak it as needed, right? No, exactly, Yasen, exactly. I mean, I think AI is going to be utilized in development in companies in some capacity, but I don't think it's going to replace developers. So I think learning the tools isn't a bad idea, but not at this stage, not at the learning stage, right? Okay. So anyway, that's my little spiel. So I don't want to do a recursive. Yeah, see, the recursive is pretty easy. So I'm just thinking of how I would do this here. I could do this. The recursive method's easier. Oh, nice, Jesse. That's true. I agree with GPT in that one. Okay, so let's try this then. Let's try the recursive approach. So we'll do const bst recur or something like that, and then we'll have. Does it take in a root as well as... Oh, no, it takes in the array. Okay. So... okay, so the array is a number. Start is a number. The end is a number. Oh wait, actually, whoops. I want to do this like this, sorry. I forgot arrow notation already, fellas. Okay. So this is our function for the recursive implementation. And then we basically need to get the midpoint, right? So we'll say let const mid equals isn't it start plus start minus end, or end minus start divided by 2 or something? And then we floor this entire thing. Actually, we need a guard condition here. So if start is greater than or equal to end, return. We just return, I guess. Okay. And then I think we just call this recursively. So then we do. Where was this here? Right, and then we get the root. I see. Okay. Starts greater than end. Okay. Return undefined. Okay. Yeah. So that's easy. Okay. Call parent. And then we'll do parent dot left child. I actually want to do getters and setters for this. Wait, no, we don't need. Get left child is just this dot left child. Right. Wait, how does it, what's the getter syntax? Again, getters, setters. Oh, it's this. Sorry. It's not arrow syntax. Return. Okay. So get left and right. And then set left child. LC number. Or no, node. This dot left equals LC. And then same with right. It's a problem. Type node undefined is not assignable. That's why. Okay. Good day, Hup Hup. How's it going? Okay, so we do parent.leftChild equals BST recur. We'll pass in the same array, and then we'll do start and then mid. And then parent.rightChild equals BST recur. Array mid +1. And then end, right? And then we'll return the parent, I think, right? I think we return the parent. Yeah, okay, that's right. And then we return BST recur of array and 0, and then array.length -1. Nice. So in theory, this should work now. And we'll use this pretty print function, graciously given to us from the Odin Project people. Dot. Oh, I need a getter for the value too. Getter and setter for the value. course. There we go. Alright, so now this should work. And then we will do our test case of this array, which will actually scramble. So we'll say, we'll put 1 here, 5, 14, 9, 23. And we'll do my tree dot pretty print my tree dot roots. Right? Oh, and then we need a getter for that. Get root return this dot roots. Good. Maximum call stack size exceeded. Okay. So obviously we have. Is it this maybe? Oh, that looks like shit. It does not look right. It's definitely something. Thoughts on free code camp, MKM? Okay, so this is kind of my thoughts on free code camp. I think it's great if you are brand new to programming, because especially for like if we go to a lesson here, like let's see, build a curriculum online, right? Well, actually, it's a bad example. Let me go to like another lesson. See how hand-holdy it is? Like it kind of there's two things. One, you don't have to set up the environment on your own. You can program it right in the browser, right? And two, the instructions are very detailed. And so that's great if you have no idea what you're doing, and you kind of want it to hold your hand a little more, which is fine. If that's how you learn, free code camp is better than Odin Project. But Odin Project, the reason I chose it is because it's a lot more open, and it allows you to kind of approach problems the way you want to, right? Like, for example, I'm doing all of the Odin Project with TypeScript instead of JavaScript because that's what I want to do, right? So, that's just one example, but there are many others. It's a lot more open-ended. So for me, the Odin Project made sense, but for absolute beginners, I think free code camp would actually make more sense because the Odin Project might be a little bit too open-ended, right? You might get lost or discouraged because there's not enough guidance. So, yo, anime, how's it going? I have a feeling this should work, but I don't know why it isn't. This pretty print thing is not very good. If start is greater than or equal to end, return undefined. Need start plus. Oh, I see. Start plus math.for. Yeah. Okay, so that's right. Oh, it was yes. That's why. I have to do mid -1 because I can't include itself, right? So that's why we're hitting the call stack error, because we were recursing on the parent, which is not what we want to do. So, yeah, that makes sense. Okay. So this looks like garbage, but yeah, I don't think this is right, but we can at least print the I don't know how we do this actually. Maybe we just print the root. Console.log. Right. Get rid of this pretty print BS. Yeah, I use TypeScript anime. And I'm doing pretty well. Mic broke, though, so I'm using my Mac's built-in microphone. Although, Yasin earlier said that it wasn't an issue. You're watching a tutorial? Nice. What tutorial? Anyway, so let's see. Okay, so we have, okay, so 23 is the midpoint, which is wrong. It should be 9. The left child's 1, and the right child is 5. And then 27, 9, 14. Yeah, so that's obviously not right. So is this actually being sorted, I wonder? It is not. Okay, so that's the issue, is the array itself isn't being sorted. 114. Oh, it's being sorted not by... It's being sorted by, like, as if they were strings, which is not what I want. That's stupid. Is it even possible to be programmed without being overworked? I don't know, MKM. I haven't actually worked in programming, but I will say that I do have a full-time job, and I do this on the side, and I don't feel that overworked. But, you know, it depends on your energy levels and how, I guess, much you want to work and how hungry you are. I don't know. It's kind of tricky, because I haven't really worked in software, so I can't really speak to that. Pretty print. Oh, pretty print was just a function that was given to us by the Odin Project to visualize the tree anime. But yeah, no, I don't know. I my full-time job is I'm an IT tech by day. That's my 9 to 5. So I do that, and then I do my stuff. I make supper, do that, and then I stream. But it takes up like my whole day pretty much. Oh, yo, Alchemist, how's it going? You found out about the Odin Project a few days ago. I'm on day 36. Yeah, it's going pretty well, I think, Alchemist. I mean, we've had our ups and downs, but I think it's going pretty good. We're working on a binary search tree implementation in TypeScript right now. We're almost done the JavaScript course, so we're getting there. But I'd say it's really good. I'd say I like how open-ended it is. I like that it kind of lets me run with the projects how I want to. But yeah, no, it's great. Yeah. But anyway, as of the workload, I don't know. I don't know if I'm ever going to work for a company in software, or if I'm gonna like freelance. I honestly don't know. What's the logic behind binary search? So basically, what we're doing, anime, is we are. Let me get the Wikipedia back here. Essentially, the idea is to store data such that the average lookup time, average data insertion and deletion for, like, let's say a group of elements is log of n time instead of n. Because, like, let's say you have data that's stored in an array, right? And you want to insert data in the array, or like a linked list or something. But the worst case, you'll have to traverse the entire array to insert that data, or not to insert it rather, but to search, like to find something in it, right? Like, so like let's say you have an array of stuff and you want to find the index that holds a particular value. To find that index, you might need to search the entire array, like linearly, right? But with a binary tree, because of the way it's structured, it only takes log n time to search based on a value, right? Yo, Augie, how's it going? But yeah, no, basically the benefit of binary trees is that you can search, insert, and delete data with an average of log n time complexity, whereas deletion and search for an array are log n, or sorry, n, but the insertion is constant for an array because you just append it to the end. Yeah, no problem, anime. So it's just got better time complexity, right? What's the n in the log n? So n is the input size. So n is the number of elements in your data structure. So like for an array, that would be like the number of elements in the array, or for the binary tree, that would be like the number of nodes in the tree. So like in this case, n would be 1, 2, 3, 4, 5, 6, right? Oh, it's 8:09 a.m. in Bali. I'm awake because neighbor's trying to ruin your sleep. Oh no. That is unfortunate. I usually get up at around that time. I get up a little earlier than that, actually. I get up usually, 7:45 in the morning. Anyway, all right. So, yeah, we're just trying to troubleshoot this because this sort is not working how I thought it would. So I want it to sort the numbers using their size. Okay, so I can do it like this. There we go. Okay, so this should actually fix our problem. So what are we tackling now? We're basically tackling converting an array that's given to us, like to construct a binary tree based on that, using these nodes, these node objects as the values, right? In the structure. So a node is essentially one of these, right? So a node can hold a value like a number, and it can hold its left child and its right child, right? So 9 would have a value of 9. The node 9 would have value 9, and then its left child would be this node, and then its right child would be this node. Yeah, I appreciate that, Alchemist. That's kind of like what we're going for here. You can also join the Discord that we have, and keep the community updated on your progress to kind of motivate yourself too. If that works, if you like that sort of thing, you totally don't have to. But if that kind of is what you're interested in, then feel free. So, and you can also chat about what you're learning. You can chat about your projects, stuff like that. And hey Kumar, how's it going? But yeah, that's kind of what the Discord's for. But anyway, so okay, so let's go back to it here. So then this should be sorted. Now, it should be sorted. Yes, okay, so now it's sorted properly. Yeah, and then now this pretty print should work. But I might write my own pretty print function. Pretty print. I don't think. Oh, console.log. Oh wait, what's the problem here? Oh, it's expecting a root, right? This dot or my tree dot root. Okay, so that's how the tree works. I see. Okay, I got you. So this mimics the same tree that we have here. even though it's printed sideways. So you have 9 and then 1, 23, 5, 14, 27. Yeah, cool. You usually wake 9 to 10 in the morning. You're working remotely and start at 11 a.m. Oh, I see, Ogie. Yo, Mohammed, how's it going? Oh, see, okay, Alchemist. That's really good that you have web dev as a course because I did my computer science degree and I never had a web dev course, which is BS if you ask me. But you know, I never had a web dev course. I never had a practical programming course. I never had a project building course. I never had any courses for like industry tech at all. So I had like, it was all math. It was all theory, which is fine. But again, I didn't really get any like project building experience, right? So, yeah. Okay, I forgot to start this break. I'll actually start this break now. Yeah, that's kind of like what I had too. Alchemist was like I knew like what HTML was, right? And I'm like, oh, I could probably like hack something together, but it wasn't like professional at all, right? I didn't learn off like you know, properly. Kind of felt unprepared. So, yeah. All right, so that sorted array worked. Now, if we do the test array here. We'll do the test tree. Yeah, so that looks like right, because then you go bigger and then smaller. Yeah, okay, so that looks good. That looks like correct. So I think we are done with the tree builder. And then we can do this includes. Okay, so then the insert, yeah, so the insertion is going to be a little tricky. So we'll do that insert. I thought when you get a CS degree, you're a hacker. Not at all, MCAM. You know what you are is a mathematician. More than anything. At least for my institution, like the university that I went to, you're basically just like a glorified mathematician. Ooh, one of the biggest hospitals in Bali? Nice. That's pretty cool. That's neat. Pretty much got a good life, yeah. To Ogie. Yeah, I mean it is. That's decent. Is math very important for web dev? Not as much as you think. It is, okay. It's not important. Like, especially for data structures and algorithms. It's important, but for like web design specifically, like if you want to focus on front end MCAM, it's not that important. Redux for state management? No, I don't think so, Mohammed. But no, math is important more for like back end or like systems development or like low level programming, stuff like that. Anyway, okay, so since I was a little late starting the break, I'll just skip just start a new session here because I want to get going. So let's do an includes value as a number. So then we just basically do a binary search, right? So we do let's say let node equal this dot root, and then we say while node dot value is not equal to value, then we have to check whether it's larger or smaller. So if node dot value is greater than v, then we set the node to be node dot right child, no, left, right? Because the left is the smaller one. Else, otherwise, node equals node dot left child, or right child. Okay, so what's the problem here? Node is possibly undefined. Okay, so that's good. So it's just we'll just do while node. Else if node value equals v, then return true. There we go. That should work. For an includes function. We basically just traverse. This is just basically a binary search, right? So we start at the root. So like, let's say we're looking for the value of 14. We start at the root. 14 is bigger than, okay, so we actually need to flip this. Right child. No, actually I can keep it like this. So let's say the node, okay, so let's say we're looking for 14. We start at 9. 9 smaller than 14. So we go to the right child. And then we say 23 is smaller than 14. So we go to the left child. Or sorry, 23 is bigger than 14. So we go to the left child like this. And then we find 14, right? And then if we hit a dead end, like the node is undefined, then we return false because we've hit a dead end, essentially. Oh, currently stuck on C++ course? That sucks. I don't like C++ very much. Personally. I mean, some people like it. I find it kind of cumbersome. Yeah, there's a lot of definitions of web dev, right? Depends whether you focus on front end, back end, full stack, you know, web design, right? Like UI UX, that's even more front end. Like you might not even be a developer, you might just be like a designer. You know, so there's multiple definitions of web developer, I think. Anyway, this includes value should work. So let's do console.log mytree.includes. Let's just say 1, and then we'll do one where that doesn't include the 22. So true and false. Good. And I'll test this one more time. 6, 3, 4, 5. Yep. And then like 2. Yeah. Okay. So I think this includes works just fine. And then the insertion is a little tricky. So I guess we can use we can cheat a little bit here and use the guide, or just use this. This pseudocode. Let's see what this this article says. Return root. The tree is empty. Return to new node. Otherwise, recur down. Yeah, it is annoying, Alchemist. I agree. I had to learn it for one class. It was annoying. Okay, let's see. So we'll do insert value number. Root node value. Okay, so I think this iterative approach makes more sense. Yeah, okay, so this is actually not as hard as I thought it was. Okay, so we essentially traverse the tree and then find where the new node should go. And then we insert it, right? So what we'll do is but then I don't know if this is balanced then. That's the only trouble. I think it should be, I mean, it should be fine. If you're just learning the basics, doesn't matter if you're learning any language. Yeah, that's fair, yeah. It depends, like, there are some, like, language-specific features, like, that I want to learn, like, with TypeScript, like the static typing and all that. But yeah, no, I agree with you. If you're brand new to programming, the language doesn't matter so much. Okay, so let's do this here. So we'll say let new node equal new node with the value, and then we'll say while root and then we'll say if r dot value is greater than value. I don't want to do this actually. Or wait, if value, let's actually, if value is greater than r dot value, where's the, okay, I see. I see, so if it's in between. Okay. Is greater than r dot value. Or is it left? We'll return insert or just call it? Oh no, we don't. So we'll do r equals r dot left, or right, sorry. Else r equals r dot left child. Node undefined. Is less than key, else break. Ah, right. Okay, so I need to include that case. As a front end, yeah, you can leave. Of course, you can leave anime. Sorry, I didn't see your message. Front end developer, should I learn some design tools like Framer or Figma? I don't know if Caro is in the chat right now, but she might have some insight. I'm not the best with web design tools, or like knowing what's the best and what isn't. You're learning React.js. Good for you, Mohammed. React is, pretty important, I would say. I haven't gotten there yet, but I'm close. Right, so then if the data is greater than the key, then the left is temp. Otherwise, but don't we have to then transfer? The key is smaller, make it left child, else right child. But then don't we lose the I'm just confused about like any nodes underneath the current, right? Proves null, temp is new node. Yeah, I don't know. Is the timer app? It is a timer. It is a timer app. It's pomodoro.io or Pomofocus. Sorry. I'll paste it in chat, Alchemist. You can use it for yourself. It's just a free Pomodoro app on the internet. So I'm like screen recording it and putting it overlaying it on the stream. So, okay, I don't really understand fully what if this works or not. I feel like this doesn't work, but I could be wrong. So if v is greater than r dot value, then what do we want to do? R dot left child equals, or no, right child, sorry, equals v, or no, sorry, new node. Otherwise, r.leftchild equals new node. Return our root. Yeah, so I'm not fully convinced this works. Right? Yeah, exactly. Baklava. It's I don't use it strictly. I won't say like I just more so use it as a way to keep track of how long I've been streaming for. But I do take advantage of the break every now and again. But it's just kind of nice to chunk up the stream, so that like I'm aware of how long I've been streaming. I usually go for 5 Pomodoro sessions, so like 2.5 hours. Sometimes 6, although tonight I'm only going to go for 5 because I'm tired. So, but I will go for 6. Usually on the weekends I go for 6. Okay, so like if we insert a 2, then the 2 should go here, right? My tree.insert root my tree.root and then we'll pre-print it again. Now I don't think this is gonna work. Oh, it does. It inserts it on the at the base. Okay, so I see what's happening here. So the problem with insertions is that the tree may be skewed, right? So it's not balanced. Doing it this way is not balanced. So to keep the tree balanced, we would have to reconstruct it, right? So this insertion works fine, but then we could also rebalance the tree. So let's see. Be sure to insert a way that preserves the binary search property. I think it does, just fine. Because then we go 8, 4, 1, 3, 2. Yeah. See. Yeah. This doesn't preserve the balance, so we would need to rebalance. Yeah, fair, Alchemist. I think, honestly, can I be real? I get that, because I had a similar experience with when I was studying for school. I think when you live stream to an audience of people, it kind of makes you more motivated to actually work, because then you feel like you're like, you know, I mean, whether or not people enjoy what I make is one thing, but at least you delude yourself into thinking that people care. So it kind of helps with motivation, at least in my case. I don't know. Your mileage may vary, but that's kind of why I started this. Okay, so there's how do we rebalance this? I could rebuild the tree, I guess, or something. So let's see if the function works if it's called with a value that's already inside of it. Yeah, see, so if the function's already inside of it, then it should do nothing. Or so if this dot includes v term, right? That's good. Okay. Yeah. Okay. So yeah, again, this insertion works, but it doesn't preserve. Because then I could just do like, if I have, like if we insert like 24, 25, 26, for example. 24, 25, 26, 27. Then we get this, right? Which is not what we want. So if you insert a lot of consecutive values, you could get this weird linear shit happening, right? So we would want to rebalance the tree with the insertion method that I currently am using. Oh, you used to record yourself? Nice. That's, yeah, again, that's kind of why I'm streaming, right? We're console logging something up here. Oh yeah, this. Yeah, it is skewed baklava, exactly. So the 24 goes... So what should happen is the 24... Well, actually, let me think about this. So the 23, if this was balanced, you'd have, instead of a 23 here, you would have a 25, right? I think. And then you have 26, 27, and then 24, 23. So instead of a depth of 1, 2, 3, 4, you'd only have a depth of 2. Right? So we need to rebalance the tree. But then this entire structure might change as well. But I don't know if we need to... Oh, okay, so here... here it asks us to write a rebalance function. So, you know what? Given that we have to write a rebalancing function here, I'll just leave the rebalancing for now. Because that's part of the assignment for later. So then I'll do a delete element method as well. And then we'll do v. Actually, I don't even need the root for this either. Do you have to keep the root as is? Like, don't change it? No, it could necessarily, in the rebalancing baklava, the root could change, right? Because you're essentially reconstructing the tree. So how I would do a rebalance is I would get an array based on a tree traversal, and then I would basically call the build tree function on that array again. So it'd be fairly simple. Baklavas in the desert. Okay, I'll take another quick 5-minute here. Why are we... Oh, because I'll change the requirements here. Also call it insert node to be consistent. Okay. Okay. Baklava the goat. Are you asking me about baklava or alchemist? Because if you're asking me, I do have a CS degree. I just pretty rusty. I'm not gonna lie. But I think I can handle this delete node function without looking at the documentation. So it's essentially just another traversal, right? Oh, you mean dessert? Yeah, because baklava is a dessert. It's not a desert. Or is it a desert? Oh, yeah. See, I thought it was a dessert. That might be like an English quirk. Because a desert is very different from a dessert. The dessert, like the food, is 2 S's. And a desert is like a 1 S, and it's like a place with a bunch of sand. It's a different word. That's okay. I was just confused for a second what you guys were referring to, because I was like, is baklava a desert? No, it's a dessert. Yeah, no worries, Alchemist. I was just a little confused. But yeah. I think we'll do this delete item, and then we'll do, depending on the success, we'll do another function. Hopefully we only have 1 or 2 more days of this CS content, and then we'll get on to the battleship project, which will be fun. We're gonna build a battleship clone. And that'll wrap up the project here. And then I'll probably do the intermediate Git stuff in my own time. 2 a.m. here running on 2 Red Bulls and Hope. Dang, are you in Europe? That's tough. It is only 8:47 here. Desert is the correct spelling. Fight me. No. Because if I look up a desert, I don't know, like if I do desert. It's a area often covered with sand or rocks where there's very little rain. So, anyway. It's no big deal though. Does not matter. Oh, Bosnia, nice. What's the course I'm following, Baklava? It's called the Odin Project. You can check out the link here. It's a free and open source web dev curriculum. If I go to like community, let's see. Oh, that's the Discord. That is not what I wanted. I thought it was going to take me to some other page. Oops. Dashboard, yeah, okay. Anyway, yeah, it's just it's a free and open source web dev curriculum. Okay, there we go. I think I'm gonna do 25 more minutes, guys, and then I'm gonna dip for the night. Because as it turns out, working 8 hours and then doing programming, it's kind of tiring. But again, I'm still committing to 5 Pomodoros. Because for a while I was doing 3-hour streams in the evenings, and those were kind of long. So I think 2.5 is better. But anyway, okay. So let's get back to this delete node function here. So essentially, we want to do a traversal. So we'll say if not r return, just return, I guess, and then we'll say while r. Say if v is greater than, actually if v is equal to r.value, then we handle the deletion. Otherwise, r equals r dot. So if the value is greater than, we want it to be the right child. Otherwise, it's the left child. Then we handle the match here. Did I consider taking some leak code questions? Some people recommended that to you. Yeah, I have done some leak code, Baklava. I haven't done it in a bit, though. I'm kind of falling off the train. It's good, though. It's a good exercise. Like, I do have a leak code. I have a leak code account, but I probably haven't logged into it in a while. But yeah, I have a leak code here. Yeah, as I say, I haven't done it in like a week. But recently, you practiced some advanced concepts like MVC architecture. What is the best way to learn about these advanced concepts like design patterns? I honestly wouldn't know, Mohammed. Like, I think the best way, at least based on like my understanding, is probably the best way to learn these things is to just build example projects, right? Like the best way to learn, at least in my opinion, is by application, like by doing, right? So if you have you could Google like example projects that include X design pattern, right? And then maybe, whether it's AI or something, gives you suggestions for project ideas to practice that, or maybe you find a blog post or a Reddit post or something. You could even ask maybe on Reddit or something like that. Project ideas to practice that design pattern. Then you can kind of run with that and build the suggestion and practice, right? And then obviously consult documentation. Do your research as you're building the thing, and yeah, kind of go from there. That's what I would do if I was approaching that. Okay, so let's see. So we want to insert the value. Okay, so obviously we want to delete the value. So we found the node that contains that value. So then we have to delete it. And I think to do that, we also have to hold the parent. Right? So we have to do, let's just say current. Let's call this node, actually. And then I need to set the parent as well, because we need to keep track of the parent for the purposes of the deletion. So then we need to say parent equals node. Nude. Okay, so that should be good. I don't know why this is not working. The triple equals is mental, yeah. It's because what that does, Baklava, is it not only checks equality, but it also checks that the types match. That's what the triple equals is for. It's for type safety. It's stupid though, I agree. Because if I just did this, then v could be a string and node could be, like the value could be, like one could be a number and one could be a string and they could still equal. Like if you just did a double equals, then like 23 equals 23 would be true, right? Yeah. But then you would do, if you did 23 equals 23 is false, right? Because they're different types, because this is a string and this is a number. So it's kind of ridiculous, I agree. I don't know why this is giving me flack here. Parent is assigned but never used. Okay, yeah, because we'll use it here. Okay. What do I need to do? So we have the value. So then we need the parent. So then we'll say, we'll check if the we can actually just update the parent dot just trying to think about this. So we have the parent left and the parent. So we're deleting a node. We're deleting this node. And we look at the 2. And if the we want to get the left child. Just got to think through this logic for a second. I think we got to check whether the parent or the current node is the left or the right child of the parent, right? So we'll say if node is parent dot left child, else if node is parent dot right child. Actually, I'm not sure it matters. Oh no, yeah, it does, obviously, because we're setting the parent left child and right child. Yo, Mario, how's it going? You started learning coding today. Have fun, came here to sub and wish you good luck. I appreciate that. Oh, sorry, Marlo. Sorry, not Mario. I'm stupid. I'm sorry. I messed up your name. Marlo, yeah, I appreciate that, man. What programming language are you learning? Like, what kind of coding are you learning? Oh, NaN equals NaN. I think that'd be true. I'm not 100% sure though. We can test it. I think this would be true. I think. Is this? Oh, okay. So this condition will always return false. There's the answer. Baklava. So NaN equals NaN is false. Yeah. Okay. So if it's the left child, then we want to set the if node dot left child, then parent dot left child equals node dot left child. Otherwise, parent dot right child or left child equals node dot right child. And it's very similar for the so delete that, and then we need to set 14, and then we need to make the so for deleting 23. We get the left child, and we set, so that's the parent. And then we also have children of the deleted element, right? Which is the tricky part. I think there's some sort of recursive thing we're going to have to do. I think this is actually not going to work, because I think there's going to be... I think this is a little bit more involved than I thought, now that I think about it. Okay, so this is a recursive implementation. Okay, yeah, this isn't gonna work the way I thought it was. Okay, let's reconvene here. Okay, so I'm just going to use this model. So let's see what it's doing. So the root's null, return root. If the root data is greater than, then we recurse. Okay, and then we find it. Okay, so we could do this. We could do this recursive method actually with this while loop. Okay, so let's see. Successors get successor. Root data is and then root dot right equals. Here's the recursive step that I need. Okay. So we're it's sort of close, not really. Okay. So I'll do the, actually I'll probably comment this out just to have as a reference, even though it's probably gonna be useless. We also want to check whether it's contained within, so we'll also say if not node or not this dot includes the, right? And we'll have a helper function, const del recur, and we'll do root node or undefined, and then value number, say x. Sorry. This is not how AR functions work. Equals this. How much time did it take you to complete the foundation course, Saish? I want to say like 15 days or so, and then if I did about 2.5 hours per day, then that's like, I don't know, like 37, 38 hours, give or take. So yeah, that's about probably how long it took me. Maybe 40. Let's round up to 40. Probably took me 40 hours. Okay. So let's see. So we start with the root node. And then we check the number of children, right? So we'll say if r.value, actually no, we'll say if not r, return r. That was what this was. Yeah. We'll say if r.value is greater than x, or if x is greater than r equals r dot equals del recur, or do I just call del recur? Just del recur r dot left child and x. Else if x is greater than or less than r dot value, del recur r dot right child x. Oh, r dot left. Okay. R dot left child equals. That makes more sense. Okay, cool. And we'll do else. And this is the matching case, which actually I might handle like this. So I'll have the matching case up here. Then we check the number of children, right? So we say if r dot left child then it's return root dot right, root dot left. Ah, okay, I see. Okay, I got that. Root or r dot right else if r right child. Do I have to else if that? I don't think so. No. This looks fun. It is kind of fun, yeah. I'm just implementing this delete node function from a binary search tree implementation. So I don't need to keep track of the parent or the node. So I can just do this. Okay, and then so we need to figure out the successor, right? So then we need to recurse on the successor. R node or undefined. And then we do okay, and it equals that, and then we get the left. So we get the smallest and right subtree. Okay, I see. Let's just say s r dot right child. Then while s or s dot left child. Actually, while s dot left child. And s equals s dot. S is possibly undefined. S. return s. This looks like JS or something, although I don't really know the codes for JS and anything related to web design. Yeah, it is. It's TypeScript. It's TypeScript. Which is like a type-safe version of JavaScript. It's similar. It's similar to JavaScript. Okay. So I think this was right. Yes. So I don't need this. I don't need this. If our return undefined. Yeah, that's fine. Okay. And then here we do the successor. So we say wants successor. Successor of r dot value equals s dot value. And then r dot right child is so I'll say if s the light theme burns. Yeah, I apologize. I'm just kind of using it as a reference to implement this code. Because I don't really feel like super thinking it through, because essentially what we're doing is if the binary search tree has 2 children, then we want to replace the deleted node with the smallest value from the right subtree, right? And the reasoning for that is because if we have, like, let me, because that'll preserve the balanced nature of the tree. Because if you think about it, the smallest value from the rightmost subtree is going to be the value that's greater than the one that's being deleted, but it's going to be the closest, right? So that the left-right children of the new node up here will be the same. That's why you get the leftmost value, or the leftmost node from the right subtree. Yes. I understand the theory behind this. I'm bad at explaining it, but that's why. It's because it's the closest to, like for example, let's say we had another node coming down here and we had 24. Then 24 is closest to 23, so, but it's greater, so then we just bubble 24 up, and then we make 24 the new value of that node. And then you can preserve this structure, and if this was 24 instead of 23, then the tree morphologically would look the same. So that makes sense. So then this should work then. So I don't need this anymore. And then I also need to call del recur on the root node, right? Oh, and then the argument v. Yeah, good. That should work fine. Maybe. So let's try it out. Okay, so let's just do this. Okay, the timer's up, but I'm just going to finish this implementation, and then we'll do my tree dot delete node. Let's see what node would make sense to delete here. Let's delete like I don't know. If we delete 8, then the new if we delete the root here, then the new node, the new root should be 9, because then that can preserve the structure. So we can delete 8 and then pre-print the tree again, and then so the root should be 9. Yeah, it worked. Okay. However, it did cut off the rest of the rest of the tree. That's not good. Cut off the entire right half. Good successor. Current. Current equals that, right? Well, S and where equals primitive child. Yeah, so this should work. Right child equals del recur. On this. Yeah, so that's a little weird. I don't know why the tree is just missing here. I don't know. Because we're assigning the right child to recur. I don't know why this doesn't work. Oh, because I don't return, that's why. Because I don't return R at the bottom here. I think that's probably why. Yeah, there we go. That's the problem. However, this 9 is kept in the tree structure, which is not what we want. Like this s dot value should be nine. Yeah, it's a 9. Okay. So I don't know why this is staying in here. It's kind of confusing. Because this 9 should be deleted, and then the 23 should go up here. Yeah, I don't know. I think I'll leave it to debug tomorrow. But Yeah, because this theoretically should work. But then here we should be getting the... Okay, so let's just like get rid of these pretty prints here. Just undefined kind of thing. Oh, here. I just don't know why this node isn't being deleted. That's the trouble. So let's say... Turn del recurs dot root. I think it's because we're not actually changing the R value. Right. So what we really want to do is we want to say this dot root equals del recur. Oh, because it's a read only. Okay, so I can do a setter here. So I wonder if this is what we want to do instead. Maybe not. Whoops. 8, 9, 9, 9. Okay, all right. I'll leave this for tomorrow. I think I've exhausted my energy for this evening on this problem. But anyway, I appreciate everybody for tuning in and chatting and watching, and I'll be live tomorrow at the same time, around between 6:30 and 7 o'clock Eastern Daylight Time, UTC -4. So if you want to check me out then tune in around then. And join the Discord if you haven't already. Subscribe if you want to follow my journey. You don't have to do either, but totally up to you. And I'll see you around.